Hello everyone, I am Himanshu Vasnani from Department of Mechanical Engineering, and today's we are studying on the subject non-destructive evaluation and testing, subject code ME419 from Unit 1, and we are studying Lecture 7 in the series. Today's topic are liquid penetrant testing, in which we will study about penetrant removal process, uses selection of a developer, health and safety precautions. So, today's learning objectives are to have a basic understanding of liquid penetrant testing, in which you will go for penetrant removal process, use and selection of a developer, and know its health and safety precautions. And the outcome will be students will have an understanding of liquid penetrant testing, in which they will understand what is the penetrant removal process, use selection of a developer, and the students will also understand the health and safety precautions. So here, let me start off with the lecture. Uh, we have studied about the LPT, liquid penetrant testing process, in the previous lecture. So we know how all this process done. Now we will start off with the current lecture. You can say any cloth or some material, so that the entrapped penetrant from the discontinuity, it doesn't get disturbed, it doesn't get removed. Okay, the motive is to clean the surface in such a way that the entrapped penetrant in the discontinuity is not removed. Okay, why? Because if the removal process extract penetrant from the flaw indication will be reduced by a proportional amount. Okay, and if the penetrant is not effectively removed from the part surface, the contrast between the indication and the background will be reduced. Okay, so we have to be careful in this. Now, removal process, as you can see in the diagram on the right hand side, how it is removing. There is a crack, and in the crack there is the penetrant filled, and now they are properly cleaning the surface. So, penetrant system are classified into four categories to the method used for excess penetrant removal. Method A is water washable, B is emulsifiable, lipophilic, method C is solvent removable, and method D is post emulsifiable hydrophilic. So each method has its importance based upon the sensitivity required. So we will discuss them. Like method C, it is solvent removal. It is primarily used for inspecting small localized areas, and this method requires hand wiping the surface with the cloth moistened with a solvent remover. Understand? In this method, what happens in solvent removal method? This method requires hand wiping the surface with a cloth moistened with the solvent remover, and is therefore too labor intensive for most production. So normally we go with method C for inspecting small localized areas. Okay. Then we go for method A. Method A is water washable. It is the most economical to apply of the different methods because it is easy to use. Okay. Now, as the name says, water washable or self emulsifiable penetrant. This method A, water washable system, it contains an emulsifier as an integral part of the formulation. So the excess penetrant may be removed from the object surface with a simple water rinse only. Okay, with a simple water rinse, you can remove it because it has an emulsifying agent already in the formulation. So next, when removal of the penetrant from a defect due to overwashing of the part is a concern, then we go for post-emulsifiable penetrant can be used. Okay, we know that we will be overwashing, might be due to some reason, either the penetrant is so much dense that we have to use it. So in that case, we go for a post emulsifiable penetrant system. In this, what happens that the post emulsifiable method are generally used only when very high sensitivity. I repeat, only when very high sensitivity is needed. So it requires a separate emulsifier to break down the penetrant. This post emulsifiable penetrant requires a separate emulsifier to break down the penetrant and make it water washable. As the name said, post emulsifiable. Okay, so we have to understand with that. The part is usually immersed in the emulsifier, but hydrophilic emulsifier may also be sprayed on the object. Okay, brushing the emulsifier onto the part is not recommended because we don't brush it. Okay, because the bristles of the brush may force emulsifiers into discontinuities, causing the entrapped penetrant to be removed. So we don't brush the emulsifier on the part, because what happens that by mistake, if the bristles of the brush may force emulsify into discontinuities, causing the entrapped penetrant to be removed. So this is not required. This we don't have to do. We have to save the entrapped penetrant into the discontinuities to effectively find them. Okay, so the emulsifiers allowed sufficient time to react with the penetrant on the surface of the part, but not given time to make its way into defects to react with the trap penetrant. So this is the sufficient time is experimental based, formulation based, which we already know when reacting. So the emulsifier is allowed sufficient time to react with the penetrant on the surface, but the time should be sufficient enough to get to the surface only. It should not give it extra time to make its way into the defects to react with the trapped penetrant. Controlling the reaction time is of essential importance when using a post-emulsifying system. If the emulsification time is too short, then an excessive amount of penetrant will be left on the surface. Understood? If the time is too short, then obviously a penetrant will be left on the surface, leading to high background levels. Why? Because the background level should also be clean. Okay. And if the emulsification time is too long, the emulsifier will react with the entered penetrant in discontinuity that I told you just now only, making it possible to deplete the amount needed to form an indication. The hydrophilic post-emulsifiable method D, is better, gives better sensitivity than the lipophilic post-emulsifiable method B. Now it's comparing method D with method D. Okay, it's saying method D is better sensitive than method D. The advantages of hydrophilic emulsifiers that they are less sensitive to variation in the contact and removal time. Okay, when a post emulsifiable penetrant is used, the penetrant inspection process includes the following steps. They are saying that pre-clean part, then apply penetrant, allow it to dwell, then pre-rinse to remove first layer of penetrant. Okay, I repeat the extra steps. Pre-rinse to remove the first layer of penetrant and apply hydrophilic emulsifier, allow contact for specified time. Then rinse to remove the excess penetrant, dry the part, apply developer, allow part to develop, and then inspect. Very easy. So these step 3 and step 4 are introduced as an extra steps when you are working with the post emulsifiable penetrant. Okay. Now rinse method and time for washable penetrant. The method used to rinse the excess penetrant from the object surface and the time of the rinse should be controlled so as to prevent overwashing. It is generally recommended that a coarse spray rinse or an air agitated immersion wash tank be used. I repeat, either you can go for a spray rinse or an air agitated immersion wash tank can be used. When the spray is used, it should be directed at a 45-degree angle to the part so as to not force water directly into the discontinuities. Our purpose is to not remove any penetrant from the discontinuity. So here it is saying when spray is used, it should be directed at 45-degree angle to the part surface so that not force water directly into the discontinuity that may be present. we have to avoid the discontinuities. We don't have to remove anything from discontinuities. Okay. So we should have to avoid forcing water into that. The spray or immersion time should be kept to a minimum through frequent inspection of the remaining background level. Now, hand wiping of solvent removal penetrant. When the solvent removal penetrant is used, care must be taken to carefully remove the penetrant from the part surface. Okay, while removing as little as possible from the flow. The first step in this cleaning procedure is to dry wipe the surface of the part in one direction using a white lint-free cotton rag. First of all, you need to dry wipe the surface in one direction. One pass in one direction is all that should be used to remove as much penetrant as possible. Okay, I repeat, one dry pass in one direction is all that should be used. One dry pass in one direction is all that. We have to be careful in that. Next, the surface should be wiped with one pass in one direction with a rag moistened with cleaner, and one dry pass followed by one damp pass is all that is recommended. So in this way we go for hand wiping of solvent removal penetrants. Additional wiping may sometimes necessary, but we have to be careful that with every additional wipe some of the entrapped penetrant will be removed and the sensitivity of the inspection will be reduced. So we have to be careful with that. So use and selection of a developer. Now here, as you can see in the diagram, how the developer is filled, and then with the application of a developer, the crack is easily visible or indicated for the inspector to inspect. Okay, so the developer here plays its role. The use of developer is most always recommended. Is almost always recommended. The output from a fluorescent penetrant is improved significantly when a suitable powder developer is used. Also, the use of a developer can have dramatic effect on the probability of detection of an inspection. Okay, this developer is so much helpful. Non-aqueous developers are generally recognized as the most sensitive when properly applied. However, the thickness of the coating becomes too great, defects can be masked. The defects can be masked. So we have to take care of the thickness of the coating. Okay, in case of this developer. The relative sensitivities of developers and application techniques are ranked, that is shown in the table. Like here, these are ranked from 1 to 10, having developer form and method of application. Like if you apply non-aqueous and wet solvent as a developer, it is usually by spray it is applied. Then if you go for the plastic film, then also you can go for spray method. Then if you are going for a water soluble development form, then you can also spray it. If you go for water suspendable, then if you want to go for water soluble, okay, then you can also immerse it if you want. If you want to go for water suspendable, then also you can also immerse it. But you can see the developer form are repeated. But here the spray form gets better ranking as compared to the water soluble. The spray form has better ranking. Okay, as compared to the uh, immersion method of application. You can see on the right hand side there are different applications like spray, immersion. So immersion is again the dry developer form. Then if you again go for fluidized bed method of application. Then if you again go for dry form, then you can air for air agitation in the cloud form. You can go for that. Then the last is developer form. In the dry form only, then you can immerse. dip inside is the method of application. So each method has a style, has each developer form has a style of application. So you can go according to your you can say availability. Now the main advantages and disadvantages of various developer types, like for dry, the advantages are the indications tend to maintain and remain brighter and more distinct over time, and this is easy to apply. But disadvantage is that does not form contrast background, so cannot be used with visible system, and it is difficult to assure entire part surface has been coated in dry form. In soluble form, then advantage is ease of coating the entire part. If you solve easily, coating can be done, but poor contrast, and it for visible system. Secondly, indications for water washable systems are dim and blurred in case of soluble developers. Okay, so dry developers have its own advantages, and soluble developers they have their own recommendations. Like suspender developer, in this what happens that advantage is it is ease of coating entire part. Then it has indications are bright and sharp. Then the white coating of good contrast can be produced, which work well both for visible and fluorescent systems. But disadvantage is that indications weaken and become diffused after time. So we have to do everything in time only. We have to take care of time, that how we have to carry out our process. In non-aqueous, the advantages are too much. So we will study with that. That very portable, easy to apply, accessible surface, white coating of good contrast can be produced, which work well for both visible and fluorescent systems. And the indications show up rapidly and are well defined. So this is the thing that we have to take care of it. Okay. In the suspendable also indications are good, but non-aqueous also the indications are good. Provides high sensitivity. But the disadvantages of non-aqueous developer are that difficult to apply evenly on to all surfaces. So we have to be careful with that. Then uh, more difficult to clean part after the inspection. That we have studied that we have to be careful. Then quality and process control. Quality control of a penetrant inspection is essential to get good and consistent result that we all know. And since several steps and materials are involved in the inspection process, there are quality control procedures for each of them. Okay. So the quality control, like there's a temperature control. Okay. Now what happens is the temperature of the penetrant materials and the part being inspected can have an effect on the results. Temperatures from 29 to 49 degrees, 27 to 49 degrees are reported in the literature to form optimum results. So we have to, if you want to get the optimum results, then we have to maintain the temperature of the penetrant materials and the part. Okay, temperature of the penetrant material and the parts, not anything else. The temperature of the penetrant material and the parts. The temperature between 27 to 49 degrees centigrade. Many specifications allow testing in the range of 4 to 52 degrees centigrade. Raising the temperature beyond this level will significantly raise the speed of evaporation of penetrants, causing them to dry out quickly. Okay, many specifications allow testing in the range of 4 to 52 degrees centigrade. I have once again, that many specifications allow testing in the range of 4 to 52 degrees centigrade. This temperature is having very variation. Okay. Then raising the temperature beyond this level will significantly raise the speed of evaporation of the penetrant. Okay. Now evaporation of penetrant can also take place. So it will lead to? It will lead to causing them the dry out quickly. The penetrant may dry out. Okay. So we have to be careful with the temperature also. So the surface tension of most materials decreases as the temperature increases. Raising the temperature of the penetrant will increase the wetting of the surface and the capillary forces. Okay, so we have variations in that. Of course, the opposite also true. So lowering the temperature will have a negative effect on flow characteristics. So the temperature should be maintained. If it is low, then what happens that flow characteristics are disturbed. If it is high, then also it has its possibilities. So we have to be careful and maintain the temperature. It should be controlled. Okay, we have to maintain the temperature. Then penetrant quality control. The quality of a penetrant inspection is highly dependent on the quality of the penetrant material used. Obviously, what material we are using, This has a effect. This has a you can say effect on the penetrant material, on the quality of inspection. Sorry. So only products meeting the requirements of an industry specification such as AMS 2644 should be used. This is the specification of the from the of for industry. Deterioration of new penetrants primarily results from aging and contamination, obviously. So virtually all organic dyes deteriorate over time, resulting in loss of color or fluorescent response. But deterioration can be slowed with proper storage. So we have to store the penetrant in such a way that they don't get deteriorate faster. Okay, so when possible, keep the materials in a closed container, protect from freezing and exposure to high heat. So in this way, you can control the quality of the penetrant. Contamination can occur during storage and use. Of course, open tank systems are much more susceptible to contamination than our spray systems. So we have to be careful with that. Regular checks must be performed to ensure that the material performance has not degraded when the penetrant is first received from the manufacturer. A sample of the flash solution should be collected and stored as a standard for future comparison. So we should take a sample out of the stock regularly for checking, for understanding that okay, what kind of stages are working there. If we are storing the penetrant, the standard specimen should be stored in a sealed, opaque glass and metal container. Penetrants that are in use should be compared regularly to the standard specimen to detect any change in the property or performance. So whatever you are using, that should be regularly be in touch with the standard specimen so that you are able to understand if any changes are there or not. If you want to find out, you can detect any changes in the properties or performance. Now, dual quantity control. Dual means filling up of material or sorry, a penetrant into the crack by capillary action. So in the diagram also you can see the red penetrant is filled inside the uh, cracks with the help of capillary action. So dwell times are usually recommended by the penetrant producer or required by the specification will follow. The only real quality control required in the dwell system process is to ensure that minimum dwell is reached. There is no harm in allowing a penetrant to dwell longer than the minimum time as long as the penetrant is not allowed to dry on the part. The penetrant should not dry. That is the main thing. Why in liquid form it may take time. At least it may take more than minimum time. It's not a big deal, but it should not dry. Okay, minimum time is decided by the branded producer or the specifications that are available with us. So minimum time is not a big deal. You can go beyond the minimum time, but it's not allowed to dry on the part. To dry on the part will lead to some other consequences. So emulsifier bath quality control. So quality control of the emulsifier bath is important and should be performed as per requirement of the applicable specification, like lipophilic emulsifier. They mix with penetrants, but when the concentration of penetrant contamination in the emulsifier becomes too great, the mixture will not function effectively as a remover. Okay, the mixture will not function effectively as a remover. Standards require that lipophilic emulsifier can capable of 20% penetrant contamination without a reduction in performance. Okay, so when the cleaning action of the emulsifier becomes less than that of new material, it should be. So we have to be careful that what is the capability of penetrant and it should not contaminate. Okay, the performance should not be reduced. So we have to maintain the quality. Okay, now hydrophilic emulsifier. Hydrophilic emulsifier have less tolerance for penetrant contamination. Means they contaminate. The penetrant tolerance varies with emulsifier concentration and the type of contaminating penetrant, obviously. In some cases, at less 1% by volume penetrant contamination can seriously affect the performance of an emulsifier. So the the performance can be infected with the emulsifier also. So we have to be careful with that. Emulsifier concentration and contact time. The optimal emulsifier contact time is dependent on the number of variables that include the emulsifier used, the emulsifier concentration, and the surface roughness of the part being inspected. Major these variables are there that emulsifier use, the emulsifier concentration, and the surface roughness of the part being inspected. and other factors are also there. But these three are important for the part being inspected. So usually some experimentation is required to select the proper emulsifier contact time. See, we have data. Whatever the experimentation is done, they store them for further control. So based upon the data that is available with us, we can choose the proper contact time. Okay. Then wash quality control. The wash temperature, pressure, and the time are the three parameters that are typically controlled in a in a penetrant inspection process specification. A coarse spray or an immersion wash tank or with air agitation is often used. So we know that the temperature, pressure, and time. Remember these three, you can say parameters that are specifically controlled in penetrant inspection process specification. So the temperature range of the water is usually specified as a wide range, for example, 10 to 30 degrees centigrade. The wash time should only be as long as necessary to decrease the background to an acceptable level. Yes, that is the main purpose. That the background level should be clean. That is the thing. Okay. When the spray method is used, the water pressure is usually limited to 276 dpa that we all have to maintain. Now, frequent visual text on the part should be made to determine when the part has been adequately rinsed on. Okay, so we can do inspection with that. Now, drying process quality control. The temperature used to dry parts after the application of an aqueous wet developer or prior to the application of a dry powder or a non-aqueous wet developer must be controlled to prevent drying in the penetrant in the flaw. Okay, so we have to maintain drying process quality control in this way. To prevent harming the penetrant material, drying temperature must should be kept less than 71 degrees centigrade. Remember, the drying temperature should be kept to less than 71 degrees centigrade, and the drying time should be limited to a minimum length necessary to thoroughly dry the component being inspected. Control. The function of the developer is adhere to highly porous layer. Parts for the penetrant to be moved due to capillary action. So developers are either applied wet or dry, but when desired end result is always a uniform, highly porous and with surface layer. Since the quality control requirements for each of the developer types is slightly different, they will be covered individually. So how they will go? We'll go back. Then dry powder developer, as you can see in this diagrams in the below, that how the developers are applied. Dry powder developer is applied, or the spray is to the spray it is applied. So a dry powder developer should be checked daily to ensure that it is fluffy and not caked. Cakes, like you can say bundles of uh, cakes, are not present in the powder. So we have to be checked. It should be free flow. And it should be similar to fresh powdered sugar or not granulated like powdered soap. So it should also be relatively free from specks of fluorescent penetrant material from previous inspection. It should be free from that also. This check is performed by spreading a sample or a developer out and examining it under ultraviolet light. When using the developer, a light coat is applied by immersing the test component or dusting its surface. After development time, excess powder can be removed by gently blowing on the surface with air not exceeding by 35 degrees. So we have to maintain the dry powder in such a way that it doesn't get caked or it doesn't get granulated like powdered soap. Okay, we have to make it free from you can say specks of fluorescent pendant material that was if available from the last inspection, previous inspection. Okay. Now, wet soluble suspended developer. The wet soluble developer must be completely dissolved in the water, and wet as a suspendable developer must be thoroughly prior mixed to application. The concentration of powder is carried solution in the carrier solution must be controlled in these developers. Like the concentration should be checked at least weekly using a hydrometer. We have also instrument in this way. And how to check the concentration. And using a hydrometer to make sure it meets the manufacturer's applications. To check for contamination, the solution must be examined weekly for both white light and UV light. For powder form, you have to examine daily, but for wet, you can examine weekly. Okay. For some specifications, require that a clean aluminum panel be dipped in the developer, dried and examined for indications of contamination by fluorescent penetrant, penetrant materials. Okay. So they are normally saying like that only. And these developers are applied by spraying, following, or immersing the component. Okay. We have all the options available in wet soluble suspendable developers. They should never be applied with a brush because brush will remove the material from the that cracks. So we should not do that. Then the care should be taken to avoid heavy accumulation of the developer solution in the crevices and recesses. Now solvent suspendable. Solvent suspendable developers are typically supplied in sealed aerosol spray cans. Since the developer solution is in sealed vessel, direct check of the solution is not possible. So the way that a developer is dispensed must be monitored. We have to monitor it. Okay, the spray developer should produce a fine, even coating on the surface of the part. Then you have to make sure that the can is well shaken and apply a thin coating to a test article. When the spray produces spatters or an uneven coating, then the can should be discarded. When applying a solvent suspendable developer, it is up to the inspector to control the thickness of the coating. The thickness here matters. With a visible penetrant system, the developer coating must be thick enough to provide a wide contrasting background but not heavy enough to mask indications. When using a fluorescent panel system, a very light coating should be used. Okay, invisible you can go for higher coating, but in a very fluorescent, a very light coating should be used. The developer should be applied under white light and should be appear evenly transparent. Now, development time, the part should be allowed to develop for a minimum of 10 minutes and not more than 2 hours before inspection. Okay, so very easy to understand that the part should be allowed to develop for a minimum of 10 minutes or not more than 22 hours for inspection. So this is a common idea. The light quantity control, you can see in the diagram on the right hand side how it is visible, the facts are visible. So here by this you are testing it. So proper lighting is of great importance when usually inspecting the part for the penetrant indication. Obviously the lighting required are different for inspection conducted using a visible dye penetrant than they are inspection conducted using fluorescent dye penetrant. So let me start with this, the lightning for visible dye penetrant. Then if you are using a visible dye penetrant, then how what lights can be used? Now when using a visible penetrant, the intensity of the white light is of principal importance. The inspections can be made conducted using natural lighting or artificial lighting. We can go with that artificial lighting also and natural lighting also. However, since natural daylight changes from time to time, it varies. The use of artificial lighting is recommended to get better uniformity. You have to have a better uniformity for the lights. So artificial lighting is required. So it should be white. Artificial lighting should be white whenever possible. So halogen lamps are commonly used. Light intensity is required. The 100-foot candles that is 1070 lux and the surface being inspected so that the developers that are bloating they can be easily seen. Then in the here the lighting for fluorescent penetrant inspection, as you can see on the right hand side there is inspection going on in the diagram. So here the fluorescent penetrant dyes are excited by UV light of 365 nm wavelength and emit visible light where somewhere in the green yellow range between 520 to 580. The source of ultraviolet light is often a mercury arc lamp with a filter. The lamps emit heavy wavelengths and the filter is used to remove all but the UV and a small amount of visible light between 310 and 410 nm. The visible light of the wavelength above this 410 nm interferes with contrast. It interferes with the contrast, and the UV emissions below 310 nm include some hazardous and wavelengths. So we have to use in between this 310 to 410 nm. Okay, we have to use in this 310 to 410 nm. The standards and procedures require verification of filter condition and light sensitive intensity. Sorry, the black light filter should be clean, and the light should never be used with a cracked filter. Obviously, this is a small information showing that most UV light must be warmed up to dry you and should be used for at least 15 minutes before beginning an inspection so that proper light is spread. Okay, so these are small things like since fluorescent brightness is linear with respect to ultraviolet excitation, a change in the intensity of the light from area or damage, and a change in the distance of the light source from the surface inspection will have a direct effect on the inspection. So these are simple things that have been told to you that these require the proper check, and the new bulb when a new bulb is installed, you have to check it properly, and then start the inspection cycle. So that is one of the most important thing that while performing a fluorescent penetrant inspection, it is important to keep white light to a minimum as it will significantly reduce the inspector ability to detect fluorescent indications. Okay, so in this way you can go with the indications. Then light intensity measurement are made using a radiometer, that is an instrument that transfers light energy into an electrical current. Then some radiometers have the ability to measure both white and black light, and others require separate sensor for each measurement. Whichever type is used, sensing area should be clean and free of materials that we have discussed earlier also, that should be clean and free of materials that could reduce or obstruct light reaching the sensor. So uh, we are going with again the system performance check. A system performance check is typically required daily. So we have for you should have a proper maintenance or repair, or because at any time system is suspected of being out of control. So what we do that system performance checks involve processing the test specimen with known defects to determine if the process will reveal discontinuities of the required size. So we have to be careful with that. And the specimen must be processed following the same procedure used to process the production parts. And the ideal specimen is a production item that has the natural defects of the minimum acceptable size. So we have to be careful with this system checks, like how this checks are done. There are some universal test specimens that can be used if the reference part is not available. The most common used test specimen is GMO panel, which is used for fluorescent penetrant system. So here it is showing that how this panels, the test specimens can be used as a reference part, and the defect have been and the quality has to be maintained. So you can say that the chrome plated section is impacted from the back part to produce a starburst set of cracks in the chrome. There are five impacted areas with a range of different crack sizes corresponding to five level of authority. So we have to be careful. Then the care of system performance check specimen is critical, so specimen should be handled carefully to avoid damage. And there should be a clean thoroughly between uses and storage in a solvent is generally recommended. So before processing a specimen, it should be inspected under UV light to make sure that it is clean and not readily producing indication. You can see in the diagram also how the indications are shown, how it is you can shining. Okay, you can see the marks on the specimen. The nature of the defect can have a large effect. Obviously, the nature of the defect will have a large effect of sensitivity of the liquid penetrant inspection. So sensitivity, you can say that it is the smallest defect that can be detected with a high degree of reliability. So typically the crack length of the sample surface is used to determine the defect size of the defect. However, the crack length alone does not determine whether the flaw will be seen or go undetected. Okay. The volume of the defect is likely to be more important feature. The flaw must be of sufficient volume so that enough penetrant will bleed back out to a size that is detectable by the eye or that will satisfy the dimensional threshold of the Florence. Okay, so here you can see in the diagram, sorry, the diagram is showing the example of fluorescent penetrant inspection probability. What example is showing? Fluorescent penetrant inspection probability. So this is the probability detection. So how this is increasing time. This can be studied with the help of this graph. So we have a this is based upon the data that is available with the previous test. They have made this graph. Okay. Then the general penetrant testing is more effective at findings. So in general, penetrant testing is more effective, and how the small round defects, then small linear defects are removed, then deeper flaws, then shallow flaw, then flaw with narrow opening at a surface, then wide open flaws, then flaw on smooth surfaces, then on the rough surfaces, then flaw with rough fractures surfaces, then smooth fracture surfaces, then flaw with under tensile or no loading, then flaws under compression. Okay, the flaw with rough fractures in the surfaces, then smooth fracture surfaces. This is also important. Then flaws under tensile or no loading, then flaws under compression loading. So this is effective. And health and safety precautions. Should be there that stored in small quantities, well ventilated areas, and so emission should be avoided. Eye protection should be properly used. Gloves should be properly used to avoid contact with the chemicals. Ultraviolet safety that it should have a limit, so it should be used within limits because too much exposure will be harmful to skin and eyes. So let me start with the MCQ. So if the penetrant is not effectively removed from the part surface, the contrast between the indication and the background will be reduced. Okay. Now second, in LPT, the penetrant removal procedure must effectively remove. LPT is liquid penetrant testing. The penetrant removal procedure must effectively remove the penetrant from the surface of the part without removing an appreciable amount of penetrant from the discontinuity. It is true or false. So it is true. Then third, water suspendable developers are applied to parts in the same manner as water soluble developers. Then the parts are dried using warm air. It is true. Then these penetrants contain an emulsifier that as an integral part of the formulation. So the excess penetrant may be removed from the object surface with simple water rinse. So that is what is called as water washable emulsifier or self emulsifier. Then next, these penetrant methods are generally only used when very high sensitivity is required. I repeat, these penetrant methods are generally only used when high sensitivity is needed. So it is post emulsifiable penetrants. These penetrants require a separate emulsifiable to break down the penetrant and make it water washable. This is post emulsifiable. The only real quality control required in dwell step of the process is to ensure that a minimum dwell time is reached. That is true. To prevent harming the penetrant material, drying temperature should be kept less than 71 degrees centigrade. With a visible penetrant system, the developer coating must be thick enough to provide a white contrasting background but not heavy enough to mask indication. So it is true. Then which parameters are typically controlled in a penetrant inspection process? Important. Okay. Uh, so these are the references. Excuse me. with the references which may be helpful to you to study properly with your subject, which may you may refer later on. So, in today's lecture, I have tried to explain you what is the role of penetrants and developers and types of developers and penetrants and quality control. So, if you want to study more in that, you can go with these references. So, thank you all for today.